So the first step in using a mathematical induction proof, or doing a mathematical induction proof, is to show the base case. You have to make sure that it works for the first term, because if it doesn't work for the first term, it's not going to work for any of them. So what I'm going to do is I know the first term is 1. The first sum is 1. So what I'm going to do, go over here to the sum formula, and if it's the first term, n equals 1. So I'm going to come over here and show that 1 over 3 times 1 plus 2 is indeed equal to 1. So that's going to be 1/3 times 3. Well, 1/3 of 3 is 1, so the base case is verified. So because base case is verified, now we want to show that it works for any term number. So what we're going to do is the first step in this is called the k case, at least that's what I call it. So every place you see an n, you're going to replace with k. So 1 plus 5 over 3 plus 7 over 3 plus, I guess I should have a plus here, 2/3 k plus 1/3 equals k over 3 times k plus 2. And that's the k case. So the next step is we're gonna do the induction step, and that's where we're saying, okay, we got the k term in there. We want to go one more term. So I call this the induction step. And what we do with the induction step is we know that the old sum works, or at least we're pretty sure it works. It worked for the base case, so we'll assume it works for the rest. So when you do the induction step, we're going to take the old sum plus one more term. That has to equal the new sum. So the old sum we know is k over 3 times k plus 2. And now we'll do one more term. And the way we add one more term is we're going to take the k in our formula and we're going to replace that with k plus 1. And we'll do that on both sides. So I'm going to leave a space. I'm going to write that over 3. I'm going to leave a space and write in the 2. And every place I had a space or a k, I'm going to write in k plus 1. So that's my setup for my induction step. Now the last step will be to make the left-hand side equal the right-hand side without multiplying across the equal sign. So first off, I'm going to work on the right-hand side, get that cleaned up just a little bit. I know that this will be k plus 1. Oh, let me go back to white here. Shows up better on this black background. So k plus 1 over 3. And inside the parentheses, does that become k plus 3? Now, it may be easier to leave it like this. It may be easier to multiply this out. I don't know. Let's try multiplying it out. So that's going to be, because this is over 1, I can just multiply the numerators and multiply the denominator. So I know I'm just going to FOIL, so I'm going to get k squared plus 4k, 3k plus 1k is 4k. And then 1 times 3 is 3. And that's all going to be over 3. So we'll leave that alone now. I don't know which way it'll be easier, but we have both of them. Now let's go work on the left-hand side. I see, what do I see? I guess let's do this. Let's distribute. So I'm going to get k squared over 3 plus 2k over 3. All I did was distribute that through. And then I'm going to distribute the 2/3 through. So 2k or 2/3 k over 3 plus 2/3 plus 1/3. Okay. So now let's combine all our like terms. So k squared over 3 plus, don't we get 4k? I put those together. I get 4k over 3. And that's going to give me 3k, or 3 over 3. And I could write that as 1, but I'm looking at what I wrote over here. I think I'm going to leave it. All of those numbers are over 3. All of those terms are over 3. So k squared plus 4k plus 3 over 3, and lo and behold, it's the same. So we just verified this using the mathematical induction process.